From nearly 1.5 billion kilometers away, it captured a moment no one expected. A pale blue dot, glowing softly in the darkness, suspended in the vastness of Saturn's orbit. That dot was us. Earth, seen from the other side of the solar system. Tiny, fragile, beautiful. This wasn't just a photograph. It was a reminder of how far we've come and how small we still are. That image, taken by the Cassini spacecraft in 2013, was nicknamed "The Day the Earth Smiled." And behind that smile was a mission, a machine that would journey longer, farther, and deeper than most could imagine. Hello and welcome, I'm Orion, and this is Infinite Universe NTH. Today, we begin a journey through time, science, and wonder, following a spacecraft that redefined what humanity could reach. Launched in 1997, the Cassini Huygens mission became one of the greatest interplanetary adventures ever undertaken. It gave us not only the most detailed views of Saturn and its moons, but also insights that change the way we understand planetary systems, and perhaps life itself. But beyond the data, beyond the orbits and gravity assists, there was something more. There was beauty, there was purpose, and in the very end, there was sacrifice. On October 15, 1997, the early morning skies over Cape Canaveral lit up with fire and thunder. Riding atop a Titan V rocket, the Cassini Huygens spacecraft lifted off from Earth, leaving behind everything familiar to begin a voyage no human or machine had ever taken before. It wasn't just headed for Saturn, it was headed for history. At over 6 meters tall and weighing more than 5,600 kilograms at launch, Cassini was one of the largest and most complex interplanetary spacecraft ever built. Too massive to fly directly to Saturn, Cassini would rely on a series of planetary flybys, ingenious gravity assists, to slingshot its way through the solar system. It was a feat of extraordinary precision. Like playing cosmic billiards on a moving table, scientists calculated each maneuver to the second. First, a flyby of Venus in 1998, then another in 1999. Each pass borrowed momentum from the planet's orbit, flinging Cassini forward with greater speed. In August of 1999, the spacecraft passed so close to Venus that it skimmed just 600 kilometers above the surface, yet never wavered. Next came Earth. On August 18, 1999, Cassini flew past its own home planet for the last time, performing a gravitational slingshot that accelerated it by over 5 kilometers per second. As it did, it turned its cameras toward Earth and the Moon, capturing images that would later be used to calibrate its instruments. Those early images weren't just tests. They were echoes of where it had come from, reminders of who sent it. And for a brief moment, Earth and Cassini looked at each other, one last time. After Earth came Jupiter, Cassini's final major waypoint before Saturn. In late 2000, the spacecraft passed the gas giant, sending back a stunning 26,000 images of Jupiter, its rings, and its Galilean moons. Among them, a breathtaking view of Io's volcanic eruptions, silhouetted against the swirling face of Jupiter, a snapshot of violence and beauty, frozen forever in digital memory. But even as it marveled at Jupiter, Cassini never forgot its true destination. By mid-2001, it was beyond the asteroid belt, coasting through the outer solar system, silent, steady, and sure. Its path was set, its mission unwavering, and Saturn was growing closer. After nearly 7 years of travel, countless calculations, and 3 planetary flybys, Cassini finally approached the place it had been built to study. And then, Saturn emerged. Hanging in the darkness like a glowing ornament, Saturn's rings shimmered in reflected sunlight, casting ghostly shadows onto the golden clouds below. No photograph, no simulation, no dream could have prepared Cassini or us for the real thing. What it saw wasn't just a planet. It was a world of poetry in motion. On June 11, 2004, Cassini performed its first targeted flyby in the Saturn system, passing just 2,000 kilometers above Phoebe, one of the planet's outermost moons. This moon was unlike anything seen before. Cratered, ancient, and unusually dark, Phoebe appeared to be made of rock and ice. A possible captured object from the distant Kuiper Belt. Beneath its shadowed craters, bright streaks hinted at subsurface water ice. It was Cassini's first scientific discovery at Saturn. And it wouldn't be the last. Just weeks later, on July 1, 2004, Cassini fired its main engine for 96 minutes in a daring Saturn orbit insertion maneuver, slowing itself enough to be caught in the planet's gravity. The burn was a success. Cassini had arrived. It became the first spacecraft in human history to orbit Saturn, transitioning from a traveler to a resident. As it crossed the ring plane for the first time, Cassini captured some of the most detailed images of Saturn's rings ever seen, revealing that they weren't smooth as once thought, but full of waves, ridges, and braided strands. These weren't just decorations. They were dynamic systems shaped by gravity, collisions, and invisible forces. Cassini's cameras also picked up shepherd moons, tiny satellites embedded within the rings, guiding, shaping, and maintaining them like cosmic artists. It was the beginning of a dance that Cassini would observe for the next 13 years. And barely 24 hours after entering orbit, Cassini approached Titan, Saturn's largest moon. Cloaked in a thick orange haze, Titan hid its secrets well. But Cassini was patient. With each flyby, it collected radar maps, atmospheric readings, and optical data, slowly peeling back the layers of mystery that had surrounded Titan for centuries. Saturn had welcomed its visitor with majesty, and in return, Cassini opened its eyes wide, ready to see everything. Of all Saturn's moons, one stood apart. Larger than Mercury, cloaked in dense orange haze and hiding a thick nitrogen atmosphere, Titan looked less like a moon and more like a world. For centuries, astronomers had been intrigued by Titan's size and mystery. But no telescope could see through its clouds. What lay beneath remained unknown, until Cassini arrived. In October 2004, Cassini performed its first close flyby of Titan. Its instruments pierced the thick atmosphere, revealing a surface unlike any other moon. Rivers, lakes, valleys, not of water, but of liquid methane and ethane. Titan was cold, far below freezing. But it had weather, clouds, rain, erosion. In many ways, it looked familiar. So in December of that same year, Cassini released the Huygens probe, built by the European Space Agency, to land on Titan's surface. It was a leap of faith. No spacecraft had ever landed this far from Earth, and Titan's atmosphere was unpredictable, dense, and alien. On January 14, 2005, after a 2.5-hour descent through orange skies, Huygens touched down, gently, on solid ground. And for the first time in history, we saw Titan from the surface. The images were astonishing. Rounded pebbles shaped by flowing liquids. A vast plain, quiet and frozen, but carved by something that once moved. Huygens revealed that Titan wasn't just geologically active. It had an active hydrological cycle, just like Earth, only colder and composed of hydrocarbons. And perhaps most important of all, Titan had organic chemistry, complex molecules, prebiotic compounds, all the building blocks of life, just waiting for the right spark. Cassini continued to fly by Titan more than 120 times during its mission. It mapped vast dune fields, polar seas, cryovolcanoes, and the mysterious magic islands that appeared and disappeared in Titan's methane seas. Over time, Titan stopped being a curiosity and became a candidate for astrobiology, for life, for future exploration, and that future is coming. In the 2030s, NASA's Dragonfly mission, a nuclear-powered drone, will land on Titan and fly from place to place, sampling chemistry and searching for signs of life. But it all began here, with Cassini, and with one small lander that gently touched down on a cold, distant world that somehow felt oddly familiar. At just 500 kilometers across, Enceladus didn't seem like much at first. A frozen moon, small, bright, and battered. But Cassini saw something the others had missed. During a close flyby in 2005, Cassini's instruments detected something unexpected, a subtle wobble in Saturn's magnetic field. And then, particles, ice grains, vapor. Something was escaping from Enceladus. Cassini changed course. On subsequent flybys, the spacecraft drew closer until it could see them, geysers erupting from the moon's south pole, towering fountains of water vapor and ice blasting into space through long, warm fractures in the surface, nicknamed tiger stripes. No one had expected this. A tiny world, once thought dead, was geologically active. Cassini flew directly through the plumes. It tasted them. Instruments on board analyzed the material and found something astonishing. Salty liquid water, organic molecules, and hydrogen gas. In short, ingredients for life. Not theoretical, not speculative, real, measured, confirmed. Beneath Enceladus's icy crust lies a global ocean, in contact with the moon's rocky core, providing a possible energy source through hydrothermal vents, just like the ones on Earth where life began. In that moment, Enceladus transformed, from a frozen moon into a world of possibility. Over the years, Cassini made 23 flybys of Enceladus, each one bringing it closer, each one revealing more. It measured heat signatures, gravitational anomalies, and changes in the geyser's intensity. It watched the plumes brighten and fade with Enceladus's orbit, rising and falling like tides. And through it all, one idea took root. We may not have to look light years away to find life. It might be hiding beneath our feet, locked under ice, waiting for us to knock. Enceladus inspired new missions, new models, and new hope. It reminded us that life needs more than sunlight. It needs water, energy, and time. Cassini proved that all three exist here. Not in a faraway galaxy, but in our own solar system. And just like that, a tiny, gleaming moon, once overlooked, became one of the most important places we've ever discovered. While Cassini revealed breathtaking beauty and cosmic mystery, it also served a deeper purpose: to test our understanding of the universe itself, not just to observe, but to prove. One of its most profound contributions came not from Saturn or its moons, but from the empty space in between. In 2003, scientists used Cassini to conduct a test of Einstein's general theory of relativity, a cornerstone of modern physics. They transmitted radio waves from Earth, bouncing them off the spacecraft as it moved behind the sun. According to Einstein, gravity bends space-time. And the path of light or radio waves should curve when passing near a massive object. And the result? The radio waves bent exactly as predicted. Cassini confirmed Einstein's theory to a precision of 1 part in 51,000. one of the most accurate confirmations ever achieved in deep space. But Cassini's science didn't stop at relativity. It explored the composition of Saturn's atmosphere, studying its chemical layers, temperature patterns, and seasonal changes, and it captured something even more dramatic: storms, superstorms. In 2010, Cassini observed a massive system erupt in Saturn's northern hemisphere, a storm so large it wrapped around the entire planet. Known as the Great White Spot, this rare phenomenon only appears once every 30 Earth years. The storm hurled clouds thousands of kilometers high, generating lightning 10,000 times more powerful than anything seen on Earth. It was the first time such a storm had ever been observed by a spacecraft in orbit. Then came the hexagon. Saturn's North Pole is home to a bizarre and mesmerizing phenomenon, a six-sided jet stream nearly 30,000 kilometers wide. First spotted by Voyager in the 1980s, Cassini was the first to study it in high resolution, capturing a swirling vortex unlike anything in the solar system. Scientists still don't fully understand it, but Cassini gave them the clearest view ever, turning myth into measurement. And then there were the rings. Cassini showed us that Saturn's rings weren't just static bands of ice. They were dynamic, filled with waves, ripples, moonlets, and interactions that mirrored the early formation of solar systems. By watching how these particles clumped, collided, and danced, scientists could model how planets might have formed around young stars, including our own. In its silence, Cassini spoke volumes. It showed us not only where we are, but how we got here. Because space isn't just out there. It's the story of us, written in gravity, dust, and time. After nearly 20 years in space and over a decade orbiting Saturn, Cassini faced a question it was never built to answer. How should a mission like this end? The spacecraft was running low on fuel, but there was still one great story left to tell. And NASA chose a bold, poetic answer: the grand finale. Rather than drifting away or crashing into a moon, Cassini would dive, deliberately, into the space between Saturn and its innermost ring, a region no spacecraft had ever entered. A gap just 2,400 kilometers wide, surrounded by debris, radiation, and uncertainty. Beginning in April 2017, Cassini performed 22 daring dives, threading the needle between the planet and its rings at speeds of over 120,000 kilometers per hour. Each pass was a masterpiece of navigation and timing. The spacecraft skimmed the upper atmosphere, sending back readings of Saturn's magnetic field, gravity, and atmospheric composition in unprecedented detail. It passed so close that it could feel the planet's exhale. On one of these final orbits, Cassini approached Daphnis, a tiny moon embedded in the rings. It captured mesmerizing images of waves and ripples in the ring particles, gravity made visible. The structure wasn't static, it was alive. Then came the final orbit. On September 15th, 2017, after one last distant wave to Titan, the moon that had guided it into this fate, Cassini plunged into Saturn's atmosphere. Even in those final moments, it remained a scientist. Its instruments stayed online. It adjusted its antenna to keep talking to Earth. It sent data until the very last second, until the atmosphere tore its body apart. And in that moment, Cassini became more than metal and code. It became a memory. A spark of human ambition. A monument to what happens when intelligence meets wonder. It chose to end with purpose, diving into the heart of the world it had loved from orbit. And as it burned, it protected what mattered. Titan, Enceladus, and the fragile possibility of life. Cassini died not because it failed, but because it had succeeded beyond all expectation. From launch to final signal, Cassini had traveled over 7.9 billion kilometers, orbited Saturn 294 times, and changed our understanding of the solar system forever. And perhaps, in those final seconds, just before the signal cut out, the spacecraft turned its antenna not out of protocol, but out of instinct. A final whisper across the void, saying goodbye. In the vast silence of Saturn's atmosphere, a spacecraft met its end. But Cassini didn't crash. It chose to fall. The decision to send Cassini into the planet wasn't just about fuel or protocol. It was about ethics, about protecting the very worlds it had revealed. Moons, like Enceladus and Titan, held the potential for life. And if even a single Earth microbe had survived on board, it could contaminate those alien ecosystems. So instead of risking the future, Cassini was sacrificed in the present. Engineers programmed its final trajectory to dive into Saturn, where heat and pressure would tear the spacecraft apart, vaporizing it completely. In its final moments, Cassini became something more. It became a guardian of scientific integrity, of astrobiological purity, of cosmic respect. The world watched as the signal faded, a soft tone, then silence. It was 7:55 a.m. Eastern Time, and for the first time in 20 years, Cassini was gone. But what it left behind was extraordinary. Over 635 gigabytes of data, more than 450,000 images, 294 orbits, 162 targeted flybys, and discoveries that reshaped planetary science. Cassini didn't die with regret. It died with purpose, with its antenna locked on Earth until the end, with its instruments gathering information in the very atmosphere that would destroy them, with dignity, with courage. For many at NASA and ESA, it wasn't just a machine. It was a teammate, a colleague, a silent partner on a shared journey. And for all of us, it was proof that exploration is not about conquest. It's about connection between planets, between ideas, and between people across generations. Cassini gave everything it had, and in return, it gave us the cosmos. Cassini's signal may have ended, but its story hasn't. Years after its final dive, scientists are still analyzing the data it sent. New discoveries continue to emerge about Saturn's magnetic field, the density of its rings, and the mysterious rain of particles falling onto the planet. Enceladus remains a top candidate in the search for life. Titan is now a planned destination. NASA's Dragonfly mission will launch in the 2030s, carrying a drone to explore its alien surface. All made possible by Cassini's pathfinding work. And beyond the science, there's something more. Cassini's legacy lives in the minds it inspired, in classrooms where children saw Saturn's rings for the first time, in engineers who realized that math could bend metal into dreams, in artists who painted alien landscapes based on real photographs, in storytellers, just like us, who found wonder in its journey. And perhaps, most of all, Cassini reminded us that we are not apart from the cosmos. We are a part of it. That a machine built by human hands, powered by plutonium, guided by radio waves, and launched into the blackness of space, could find beauty, complexity, and meaning billions of kilometers from home. The universe didn't change when Cassini arrived. We did. Our understanding grew, our questions multiplied, and our sense of awe deepened. One mission, 2 decades, 1,000 revelations, one goodbye. But even as it vanished into the clouds of Saturn, Cassini gave us something enduring, a sense of belonging in a universe so vast and yet so knowable. So as we look up at Saturn in the night sky, We no longer see a distant dot. We see a world we've visited, a friend we've come to know, and in that knowing, Cassini still lives. Somewhere, far beyond the reach of any signal, Saturn continues to spin. Its rings still shimmer, its moons still dance. And beneath those clouds, the ashes of Cassini drift silently, now part of the planet it loved. It didn't carry passengers, but it carried us, our hopes, our science, our soul. Cassini reminded us that we are capable of more than we think, that even with gravity holding us down, our minds can reach the stars. It taught us that exploration isn't about getting somewhere. It's about becoming something, bolder, kinder, wiser. It wasn't just about data, it was about meaning. About standing on a tiny world, looking across the solar system and saying, we choose to understand. We choose curiosity over fear, discovery over doubt, wonder over limits. Cassini's legacy doesn't just live in NASA archives, it lives in you. In every question you ask, every sky you gaze at, and every story like this that you choose to listen to. Because the universe isn't a silent void, it's a conversation between stars, time, and us. And every mission, every telescope, every dream we launch into that vast blackness is us answering back. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH.